Okay, so the stream's back up and we have it up on the screen too. So back to what I was trying to accomplish earlier. What we're going to be given, or what you guys are going to be given, is this function to implement on your side. It's this thing. It's just generate sphere. Okay. Yeah, I just want you to just watch the TV with me. This generate sphere function is going to do every single thing that your that's required to get it on the card and then to draw it. So it takes in segments, rings, and a VAO, VBO, IBO, and then an index count. I'm pretty sure everybody's familiar with that. All right. So it's basically the same thing as like NM and NP. Okay. And Zyron, in reference to what you asked, is like, oh no, we didn't go over the whole, making a sphere in class. So why is that actually? Sphere with triangles, excuse me. Thank you for that correction, because we absolutely went over making a sphere. Like, I got upset about that. And this is how you're going to go about doing it. So if we were to analyze this function, okay, this math right here is what's going to be generating the positional information for us, the normal information, tangent, texture coordinates, and also the bitangent, okay? I'll go over exactly what this even means to us, okay? This vertex class right here, this vertex variable is a member of AIE vertex. This is the same thing as the vertex class that you guys have, with a couple of additions. Okay, those additions being normal, tangent, and text coord. Okay, these indices right here. This is just, yes. Normal map. You're going to be using the tangent to, we'll go over it. It's going to be for the normal map. All right, and if you don't know what that is, that's totally fine. But it's going to be very relevant for whenever we're using the tangent to derive what these positions are inside of the actual vert space, like the tangent space. Okay. When we do that lecture, it'll make more sense. We actually don't need it for what we have, but we will visualize it, and you can kind of make an assumption from there. And then the rest of this thing is pretty much the basic, the basic setup. So where did we stop at? Well, where we stopped at before I turned the stream off was we needed to have a camera before we can do anything. Everybody knows that we need a camera. And then I mentioned about how I'm making the near clip plane 1. Okay, so the view frustum is going to start, the camera's going to have an origin, and then it's going to have some plane in front of it. We have to define the distance from origins from that to that plane, and then we need to define how far it's going to be from it. So setting it to 1 can alleviate some of the transparency type problems that you're having. So so we have all of this. Okay. So what we do after we make the camera is we're going to call the generate sphere function. Okay, the generate sphere function is going to give us the information that we need and also populate that information to the card itself. Okay, so generate sphere is the first two values are going to be numbers. Okay, so what we'll do is we'll give it 32 segments, 32 rings, and then we're going to give it the VAO, VBO, IBO, and some index count variable. Notice that they're passed by reference, so whenever the function's done executing, those variables are going to be different whenever they make it out on the outside. Okay, those variables are going to be MVAO, MVBO, MIBO, and then some index count like this. Okay, so what I'll do is put a breakpoint and then make sure that we're actually getting information into the VAO, IBO, all the things that I passed into it. Okay, How do I know if it worked? Well, if those numbers don't come back as like some huge number or a negative number, then we're pretty much good to go. In which we see that the VAO got bounded to 6, VBO is 6, IBO is going to be 7, and then the index count is going to be 6336. Okay, so it's looking pretty hot so far. All right. So we've successfully generated a sphere. So if we watch this thing go, we're going to hit the app run, and you're going to get this. Okay. The reason that we have this is because we're not sending anything to the card itself. Okay. We have no information that's actually telling the shaders how to draw, nor can we even make assumptions about how these shaders are even set up. Okay. So if we actually look at the shaders themselves, right here, so we're going to be using something called, we call it FongVert and then FongFrag. Well, the FongVert right now is only taking in one uniform, okay, being projection view model, and then it's also receiving some position, okay, so in vec4 position. So this is the, I believe the syntax is layout location equals 0. That's the syntax, right, for the shader? Yeah.
No, I can
Yeah, I mean, if you have yours up.
Yeah.
This is correct. Okay, so layout location is 0. So this is the 0th element that is currently the way. This is how we have our vertices set up whenever we're reading from the card. Okay, and that was set up inside of generate sphere. Okay, so this GL enable vertex attribute array 0, okay, it's going to be the 0th element. It's containing 4 items in it. Those 4 items are float. This right here means if those values are normalized or not. Okay, important. I mean, that's pretty important. So the total size of the vertex object, that's going to be size of AIE vertex. And then where does it start at? Okay, it starts at 0. So what I'll do is go over this guy. So for the normals, GL enable vertex attribute array 2. This is where we're going to have our normal information. So we don't have this guy, but you totally could. Okay. And this right here, if we copied and pasted that, then we would just say that it's going to enable it at 1. It's going to be roughly the same thing as the position, except for the fact that it's going to be over the size of a vec4. Any questions about that? Okay.
The order that they're in, is it based on the order that you declare, like in the class?
It would be. It would be, but that's why we use the following. So whenever you say layout and then you do location is 0, that's specifying that that is the enabled vertex attribute item. So just looking at the shader, and then looking at how we're doing enable vertex attribute array, when we say GL enable vertex attribute array 0, that's this, okay? And let me pin this out to like the side here so we can kind of look at them both. I could just like do this. Yeah. All right. So this is going to come back to whenever we start to do the uniforms, okay? And I will go over that. Wow, 5 minutes. Okay, so if you want to set up the color information, you would say layout location is 1, and then you're going to in some vec4, okay? And then we'll just say color, okay? This variable name doesn't matter. This is what matters, location, okay? So with that said, like if I wanted to add another guy, so if you're looking at GL enable vertex attribute array 2, Okay, sweet. So then you would say layout location. This is going to be at the 2. What we're going to do is in what type. It's going to be a vec4. Okay. The reason why you know it's a vec4 is because look at how many items are going to go out on it. 4. All right. And then we're going to call this guy the normal. Okay. Then we're going to continue to go about populating the shader with the following information. So this is going to be the texture coordinates, or the UVs. Okay, so in vec, ha, it's 2. It's 2 because look right here. So whenever you enable the 3, okay, you're saying, okay, well, I have a vertex attribute pointer at the 3. It's going to contain 2 elements. Those will be floats. This will be false, okay, because it's not normalized. So this is going to be a 2, and then what we'll do for right now is we'll just call it text. We'll just say UV. All right. Okay. The only thing that I missed in explaining this is that we're sending normals. Normals are going to be normalized, so we do need to specify that here. Okay. So the normals, whenever they get put on the card, what can extra information can we tell the OpenGL about it whenever it's starting to read the information is that this information is already pre-normalized. Okay, so don't go about doing all your other stuff with it. Then if we wanted to add the tangents, you can do layout location is 4 in vec4 because we have 4 of them, and then we can just say tangent. All right. Okay, so at this moment we're receiving data in based on the the layout location from the vertices. We're not like outing anything, so we're not actually sending anything to the fragment shader, okay, from the vertex shader. Okay, you totally could just put layout like do in uniforms directly into the fragment shader. That would suffice. However, if you can respect the pipeline, you can maintain some type of consistency, because sometimes you just don't know exactly where that information is going to be coming from. If you flow it through the pipe, it's a lot easier to determine if it's getting manipulated, so on and so forth. So on to the actual uniforms. All right, this is a question that you had earlier. So the things that we're missing are the actual directional light information that we had set up. So what we'll do is we're going to specify the directional lights diffuse, okay, and it's going to be just all ones. All right, the directional lights ambient, the specular color is going to be also the ones. And then we need to specify what the ambient light is going to be. It'll just be, a quarter of light. So gray. You with me? All right. So now we need to add the actual materials color. So this is going to be like the surface color. All right. So the material color is going to be, we're going to set it to the 1. Did I name this right? Oh. It's 1 o'clock. The ambient color will also be the 1, and the specular color is going to be also a 1. The material power is going to be 64. Okay, why 64? because it's 2 to a power, okay? So we're going to keep it in powers of 2 just for some type of consistency for checking here. So once we're done with this, what I'll do is I'll go ahead and say that this is the setup of the lights and color and material. We'll generate the sphere. Okay, what we'll do is we're going to make the model matrix. We're going to initialize it with some. We're basically just going to make it huge. Okay, so we'll scale it by vec35. Okay. Once we do that, we're going to need to load the shader up. And just to speed this up, because you guys are fairly familiar with like how to set the shader up, we're going to new up the shader, okay? And then we're going to load the shader, tell it what type of shader we're loading, and then tell it where it's located at, all right? This is a little bit different than how you have your guys set up based on our specifications, but it's roughly the same thing. So you load the shaders up, and then you link them to the program. All right, the program is actually housed within the shader class itself. All right, now the next thing that we need to do is give the directional light some type of like changing direction so that we can see this thing like over time change. So what we'll do is come up with some values right here to say that we're going to use cosine and sine to help us out. Okay. Okay, so on to the actual draw. We'll get to the draw. We'll send you guys to lunch, and then I'll go over it because I do feel like I'm rushing it, and I don't want to I could just copy paste everything that I have written right here, but when we come back from lunch, we'll go into the more specifics of it. And if you break it out, you could probably get everything done up into the draw, and that will maybe help you out.